Hello, my name is Fred W. Ernest. I was born on the 4th of July in San Francisco, California, and proudly served in the U.S. Marine Corps during the Vietnam War era. I studied physics at San Jose State University and have spent over 4 decades working as an expert in electromagnetic design engineering in Silicon Valley. Throughout my career, I've partnered with industry leaders, including Lockheed Martin Space Systems, Facebook, Meta, Philips Electronics NA, TV Rhineland NA, TiVo Digital, and Thermo Fisher Scientific. My focus has been on designing, testing, and implementing advanced EMC solutions that meet rigorous global standards and ensure reliable performance in demanding electromagnetic environments. You can now find a link to my new YouTube channel on my LinkedIn profile, where I share insights on achieving EMC regulatory compliance and optimizing signal integrity in high-speed PCB designs. Connect with me at www.linkedin.com in Fred Ernest. I'll make it a smooth and maybe even ducky experience. In today's interconnected world, multimedia devices have become ubiquitous. From smartphones and laptops to smart TVs and gaming consoles, these devices rely on a complex interplay of electronic components. This intricate electronics ecosystem makes electromagnetic compatibility, or EMC, compliance non-negotiable. EMC ensures that these devices can coexist without interfering with each other's operation. Without EMC compliance, we risk a cacophony of electronic noise, leading to malfunctions, data loss, and compromised performance. Imagine a world where your Bluetooth headphones constantly crackle due to interference from your Wi-Fi router, or a scenario where your TV flickered uncontrollably every time your neighbor used their microwave. These are just a few examples of the real-world problems that EMC compliance seeks to prevent. EMC compliance is not just about preventing interference. It's also about ensuring the safety and reliability of electronic devices. When devices emit excessive electromagnetic radiation, it can pose health risks to users. Moreover, electromagnetic interference can disrupt critical equipment in sensitive environments, such as hospitals and aircraft. In essence, EMC compliance is the invisible guardian that keeps our electronic world functioning smoothly and safely. It is a testament to the meticulous engineering and rigorous testing that goes into developing reliable and trustworthy electronic devices. N55232 is a critical standard within the realm of EMC compliance, specifically focusing on limiting electromagnetic emissions from multimedia equipment. It plays a pivotal role in ensuring that these devices do not disrupt the proper functioning of other electronic devices in their vicinity. This standard covers a wide range of multimedia equipment, including but not limited to personal computers and their peripherals, televisions and set-top boxes, audio amplifiers and sound systems, and gaming consoles and multimedia players. The primary objective of EN 55032 is to establish consistent methods for measuring electromagnetic emissions from this diverse range of multimedia equipment. This is achieved through a series of clearly defined test procedures and limits that manufacturers must adhere to. The landscape of EMC standards is constantly evolving to keep pace with technological advancements. EN 55432 represents a significant step in this evolution, streamlining and replacing several legacy standards that were previously used for multimedia equipment. These legacy standards, including EN 55022 and EN 55013, had become fragmented and outdated. EN 55032 simplifies the compliance process by consolidating the requirements of these older standards into a single harmonized document. This consolidation not only makes it easier for manufacturers to understand and comply with the regulations, but also ensures greater consistency and clarity across the industry. The transition to EN 55032 signifies a move towards a more modern and comprehensive approach to EMC compliance. This updated standard incorporates the latest testing methodologies and reflects the evolving electromagnetic environment in which multimedia devices operate. In 55235, ensuring immunity against interference. While EN 55032 focuses on controlling emissions, EN 55035 tackles the other side of the EMC coin immunity. This standard ensures that multimedia devices can withstand electromagnetic interference from their surroundings without compromising their performance. Imagine a world where your smartphone malfunctioned every time you drove past a radio transmitter, or your gaming console crashed whenever your neighbor used their vacuum cleaner. EN 55035 aims to prevent these scenarios by setting rigorous immunity requirements for multimedia equipment. This standard outlines a comprehensive set of tests that simulate various types of electromagnetic disturbance, including electrostatic discharges, fast electrical transients, surges, and radio frequency interference. By passing these tests, multimedia devices demonstrate their resilience against real-world electromagnetic threats, ensuring reliable operation even in challenging environments. Key immunity tests, putting your device to the test. EN 55035 outlines a battery of tests designed to assess the immunity of multimedia devices to various electromagnetic phenomena. These tests replicate real-world scenarios where devices might encounter interference, ensuring their robust operation in diverse environments. First, electrostatic discharge immunity. This test simulates the sudden discharge of static electricity, like what happens when you touch a doorknob after walking on a carpeted floor. The test involves subjecting the device to ESD pulses of varying voltages and currents, evaluating its ability to withstand these sudden bursts of energy without malfunctioning. Next, electrical fast transit immunity. EFT events are short, high-voltage spikes that can propagate through power and data lines. They are often caused by inductive loads, switching on and off, such as motors and relays. The EFT immunity test subjects the device to a series of these fast transients, assessing its susceptibility to disruption or damage. Then surge immunity. Surges are temporary increases in voltage that can occur on power lines, often due to lightning strikes or power grid switching. The surge immunity test evaluates the device's ability to withstand these voltage surges without suffering damage or performance degradation. And finally, radio frequency immunity. This tests the device's resilience to interference from radio waves, which are ubiquitous in our environment. The test involves subjecting the device to a range of RF frequencies and power levels, evaluating its ability to maintain functionality without degradation or malfunction. By replicating these real-world interference scenarios, EN 55035 ensures that multimedia devices can withstand the electromagnetic rigors of their intended operating environments. Pre-compliance testing, the foundation of EMC success. Navigating the intricacies of EMC compliance can be a complex endeavor. Pre-compliance testing emerges as a crucial step in this journey, providing invaluable insights and mitigating risks before formal testing. It serves as a dress rehearsal, allowing manufacturers to identify and address potential EMC issues early in the design cycle. Specialized pre-compliance testing equipment, often more affordable and accessible than full-fledged compliance testing setups, allows manufacturers to conduct preliminary assessments in their own facilities. This early detection of potential problems offers significant advantages. Cost savings. Identifying and rectifying issues early in the design phase is far more cost-effective than discovering them during formal compliance testing. Redesigns and production delays can be minimized, saving both time and resources, faster time to market. Pre-compliance testing helps streamline the overall compliance process. By proactively addressing potential issues, manufacturers can reduce the likelihood of costly and time-consuming delays during formal certification. Enhance product reliability. Addressing EMC issues early in the design cycle often leads to more robust and reliable products. This proactive approach minimizes the risk of electromagnetic interference causing malfunctions or performance degradation in the field. In summary, for multimedia equipment, EN 5532 and EN 5535 are the key standards used to demonstrate compliance to European EMC directive. For the most part, these two standards with country deviations are used to demonstrate global EMC compliance. The FCC allows manufacturers to use EN 55032 to demonstrate compliance to Part 15, Subpart B technical requirements. Note, FCC Part 15, Subpart B has no immunity requirements. But for global EMC compliance, you'll still need to check each country's regulations, perform additional testing or paperwork, possibly align with CISPR 32, CISPR 35, or regional equivalents. Thank you for watching, and connect with me on linkedin.com in Fred Ernest.